Hello and welcome back to Educately's chemistry course. In the previous video, we looked into the several periodic trends. In today's video, we'll be learning about the atomic model, specifically electron shells and how they function. This is what an atom looks like according to the Bohr atomic model. An atom contains protons and neutrons in its nucleus. Outside the nucleus, you see electron shells. An electron shell is the orbit followed by electrons around an atom's nucleus. An atom can have several electron shells. An easy way of calculating the number of electron shells an atom contains is by locating the element on the periodic table and checking its period number, or the row it's in. The period of an element is equal to the number of electron shells its column has. For example, sodium, or Na, is in the third period, and therefore it has 3 electron shells. Electron shells can be compared to the solar system. The electrons can be thought of as planets, which follow their respective orbits and revolve around the sun. The sun in this case is the nucleus of the atom, and the orbits can be thought of as the electron shells. Fun fact, currently the most number of electron shells an atom can have is 7. Now that we've learned what electron shells are, let's look into how they function. The electron shells contain a certain amount of electrons. The maximum number of electrons a shell can contain is calculated by the formula 2n squared, where n is the quantum number representing the energy level of the particular electron shell. This might be a little confusing, so let's look at an example. This is the model of another atom with 7 electron shells. Each shell has its own quantum number. The shell closest to the nucleus has the value of 1. The electron shell immediately outside of that has the value of n equals 2. The shell after that has a value of 3, and so on. This is the pattern used to assign values to electron shells. Here is a generalization for electron shells. The greater the value of the shell, the farther it is from the nucleus, and the higher is the maximum number of electrons it can contain. Now that we've learned about electron shells, let's put this information to use. Let's take an example. An electron has 3 electron shells. Predict the maximum number of electrons the shell can hold. Pause the video to solve the question and resume it once you're done. Hopefully that wasn't too tough. Using the general formula we learned earlier, which was 2n squared, now we substitute the value of n into the equation. Since this is the third electron shell, we take the value of n is equal to 3. Let me just take a different color here. Using the general formula we learned earlier, which was 2n squared, now we substitute the value of n into the equation. Since this is the third electron shell, the value of n is now 3. This gives us 2 times 3 squared, which is equal to 2 times 9, which is equal to 18 electrons. An atom has 4 electron shells, with there being only 5 electrons in the fourth shell. Calculate the total number of electrons the atom contains. Go ahead and pause the video and resume it once you're done. If you found that a little challenging, don't worry, it was a tricky question. The first step is to find the number of electrons each shell contains. We'll use a general formula for each shell. First, you would like to add a fourth energy level to your atom. The first shell contains 2 times 1 squared electrons, which equals 2 electrons. The second shell contains 2 times 2 squared, which equals 8 electrons. And the third shell contains 2 times 3 squared electrons, which equals 18 electrons. As we already know, the fourth shell contains 5 electrons. The next step is to add them up. So 2 plus 8 plus 18 plus 5 equals 33 total electrons. Thanks for looking at electron shells with us, and we'll see you in the next video.